explore one of those methods right now. And we're going to call that the box method. And you'll see why it's called the box method in just a second. So here we have the polynomial 3x squared minus 2x minus 5. And the first thing that we're asked is there any greatest common factor of these three terms that we can factor out first? And in this case, there isn't. We have 3x squared, a negative 2x, and negative 5. The only thing that they have in common is that they're divisible by 1. So that doesn't really help us in factoring any further. So we're going to move on to step 2. And it says that we're going to multiply the leading coefficient by the constant in our polynomial. So the leading coefficient here is 3, and our constant is negative 5. So 3 times negative 5, we get a negative 15. So now moving on to the next step, it says that we need to find two numbers, just calling them n and m, because they're unknown right now, such that the product of them is equal to the product found in step 2. So in other words, we're trying to find n times n, two numbers, that when we multiply them, we get negative 15, which is what we got from step 2. And then it also says that the sum is equal to the coefficient of our x term. So when we add n and m, we should get our coefficient of our x term, which in this case is negative 2. So in order to find these, there's a lot of possibilities for things that add together to get negative 2, but let's focus on the factors of negative 15. So we're going to look at what multiplies to get us a negative 15. And so since it's a negative, we always need to be multiplying a negative number times a positive number. That's the only way we can have a negative product. So we could have negative 1 times 15, or 1 times negative 15. We could have negative 3 times 5, or positive 3 times negative 5. So those are our four possibilities. So now all of these numbers, negative 1 and 15, 1 and negative 15, all these factors that we found, they all multiply to get negative 15. But now we need to check which ones add together to get a negative 2. So let's go ahead and add these factors together. So negative 1 plus 15, we get 14. 1 minus 15, we get negative 14. Negative 3 plus 5, we get 2. And 3 plus negative 5, we get negative 2. So here we know that we want n and m to be equal to 3 and negative 5. So it doesn't matter which one you say is n and which one you say is m, it will all end up working out the same way. So I just say that n is 3 and m is negative 5. So now in step 4, it says we're going to create a 2x2 grid. So we're creating a box. And it tells us that we are going to, in this first upper left box, we're putting the leading term of the polynomial in there, which we have is 3x squared. In the upper right-hand box, we're going to put our mx term. So we're taking our m and we're multiplying it by x and putting it in there, so negative 5x. In the lower left, we're going to have our n times x term, so 3x. And then in the lower right box, we're going to place the constant term of the polynomial. So in this case, our constant was negative 5. So now we've done everything in step 4. Step 5 tells us that we're going to find the greatest common factor for each row and column of our box and place them outside of the grid. So let me redraw my box here really quickly. So we had 3x squared, negative 5x, 3x, and negative 5. And now we're finding the greatest common factors for each row and column. So we'll do the rows first. So 3x squared and negative 5x, those have a greatest common factor of x that evenly divides both of these terms. 3x and negative 5, the greatest common factor that they share is a positive 1. And then the first column, 3x squared and 3x, they both have a 3 and x. And negative 5x and negative 5, they both have a negative 5 as their GCF. So now we are going to rewrite what we have on the outside of our box as factors. So in our original polynomial, we had 3x squared minus 2x minus 5. And now our factors that we get are x plus 1 and 3x minus 5. And there we have factored our polynomial completely. Again, if you want to check that our factorization is correct, you can use the distribution property to multiply those two factors together and see, do we get our original polynomial back? The second